All right, so now continuing on with exponential functions or equations, we're going to start to make our own. And so an exponential equation, as I mentioned earlier, can be written in the form y equals a times b to the power of x. And a little side note here is that b is always greater than 0, can't be negative. Now, the first thing is all you have to do is come up with the a and the b value, and then you have your exponential equation. Now, to find the a value, the a is actually what we call your starting amount. And b is what we're going to call our multiplying rate. That's a little bit harder to figure out, the multiplying rate. Now, a couple of things with the multiplying rate is that when b is greater than 1, that's when we have an exponential growth equation. So you won't even have to look at a graph. You can just tell by looking at the equation, if you have the equation, that if your b value is greater than 1, you have an exponential growth equation. And the opposite is that if b is less than 1, but again, can't be 0 or can't be negative, you have an exponential decay equation. So again, the equation can tell you what the starting amount is and whether you have an exponential growth or decay equation just by looking at the b value. Now, how are we actually going to use this information? Well, or this ability is example number 1. A yacht bought at the end of 2021 for $200,000 will increase in value at a rate of 4% per year. How much should the yacht owner expect their boat to be worth at the end of 2031? All right. So again, getting back to the equation, is that it's going to be in the form y equals a times b to the power of x. All right. So the starting amount, because we got to get our a and b. So the first off, the a is kind of the easier one to get. It's that this boat is going to start off being worth $200,000. All right. Now, the B part, that's the tougher part, where we have to find the multiplying rate. Now, this boat is going to be worth all of its value 100%, but you're going to add, because it's increasing, 4% per year. And so in total, your boat is going to be worth 104% more than it was the year before. Now, back to last unit, which just happened this week, is that percent is useless to us in calculations. You got to convert it to a decimal. So again, to convert a percent to a decimal, we divide by 100%. And so if I take 104% and I divide it by 100%, I get 1.04. So our exponential equation is now equal to, or going to be, I guess, I can substitute in, y equals, I have 200,000 is my starting amount. That's the money value. Our multiplying factor is 1.04. And again, you can see that is greater than 1. So this is an exponential growth equation. And then we have our x. Now, we're solving something here because the question here says, how much should the yacht owner expect their boat to be worth at the end of 2031? Well, we're going from the end of 2021 to the end of 2031, and this is per year. So our x value is that 10 years have gone by. Because our percentage is per year, then our x has to be in years, which it is. So now I'm going to substitute in that x value of y equals 10 into my equation. So I've got y equals, I got my 200,000 still. All right, my 1.04. But now we're finding a specific x, and that x is to the power of 10. All right, well, to figure out the money value, now what I have to do is just figure out my equation, follow Bedmus, so I have to do my exponent first. So this 200,000, I'm just going to leave right there. I take 1.04 and I take it to the power of 10. And to 2 decimal places, I get 1.48. All right, and then finally, I can figure out the amount that this yacht is worth. I take my $200,000, I times it by 1.48, and I end up with 296,048.86. And that means that it's worth $296,048. So I guess $296,048.86 is how much my yacht would expect it to be worth after 10 years if it had a growth rate of 4% per year. All right, let's try another one of those. Let's see here. Next up. An ant colony. Begins with 120 ants, but increases at a rate of 18% per month. How many ants will be there, or will there be 1 year later? All right, so again, our equation is going to be y equals a times b to the power of x. All right, so to find out our values, well, a, the starting amount. We're starting off with 120 ants. Now, b is we're going to have 100% of those ants, and then a month later, we're going to have an extra 18% of those. And that's going to happen every month. And our rate is per month. And so each month, it's going to change by 118%. But again, I cannot use percent in calculations. Useless to me. So I convert that to a decimal by dividing by 100%. And I'm going to end up with 1.18. All right. So my equation now is going to be y equals, my a is 120 times b, which is my 1.18 to the power of x. All right, now to answer the question, how many ants will there be 1 year later? Well, x is equal to 1 year. But here's the problem, is that our rate is in per month. So I have to convert years to months. Well, there are 12 months in 1 year. And so our x value will be 12. All right, so now I'm ready to figure out how many ants there's going to be in a year. That's not good. So let's see here. So I have y equals, got my 120 times 1.18. And now our exponent is going to be a 12. All right, so now to, again, figure it out, following Bedmus. All right, so again, I got to do my exponent first. So I take my 1.18, and I take it to the power of 12. And I end up with, to 2 decimal places, let's see here, rounding 7.29. All right, and then finally, multiplying our two numbers, we take 120, and I multiply it by 7.29, and I would expect to have approximately 874.8 ants. And there we go. All right. So again, we had to watch out that our rate was in per month, but yet what we're looking for was in years. Got to be in the same units there. All right, let's try one more here. A little bit different situation coming here. A brand new car loses 15% of its value each year. How much would a car purchased for $30,000 be worth after 6 years? All right, great question. Because every car loses, it has a depreciation rate, and every one of them are different. Now, Again, our equation is going to be in the form y equals a times b to the power of x. All right. Now, again, the starting amount here. Well, our car is starting off to be worth $30,000. Now the multiplying rate. Now that's a little bit different. Now, when you first have this car, it's worth $30,000. But after 1 year, you lose 15% of the value. And so after each year now, your car is only worth 85% of what it was worth the year before. All right. So again, percent, not good to us in calculations. Convert that to a decimal. And I end up with 0.85. All right. Now, convert our plugging in, get our equation. So we got y equals, we got $30,000. Our b value is 0.85. And we have to the power of x. Now, what you can see in this situation is this b value is less than 1, which means this is an exponential decay equation because the car is losing value, not gaining value, but losing value. All right, now it says for us, how much would a car purchased for $30,000 be worth after 6 years? And so our x value is 6 years. And, well, our rate is in years, so we don't have to make any adjustments there. That's good. And so now I can just plug in my information. All right, so I got y equals, we got our $30,000 times 0.85. And again, to the power of, this time, 6. There we go. All right, let's check it out. Y equals, again, following Bedmas. So I got my $30,000 car. And now I take my 0.85 and I take it to the power of 6. And let's see here. I end up with 0.38, going to 2 decimal places. And now finally, the value of my car now after 6 years, if you're lucky and it's nice shape, because cars do drop in value a tremendous amount. It'd only be worth $11,400. And there we go. So again, that was an example of an exponential decay question. But again, your A is your starting amount. B, you're starting with 100% of what you've got, and then you're either losing or gaining percentages after that, depending on whether you have an exponential decay or an exponential growth equation.